Today, we are starting a new unit. We are going to start talking about sequences and series. Okay, this is probably a brand new idea. Okay, I don't think that you've seen sequences and series before. Okay? So, before we start that though, real quick, let's just practice a little bit of algebra. Okay, this is like super basic. This is even like pre-algebra. Okay, simplifying expressions that look like this. Okay, so take 30 seconds and try these, simplify these two expressions here. It's not too Well, last week for air testing, I had to take them all down to the gyms. Yeah.
Do you have an air test today? Hey, go.
There is no air test today.
Here's the calculator for your problems.
It's not going to solve all your problems.
Try.
Well, that's most of your problems. Well, that's good.
Oh, look at billboard saying, stay frosty, don't do fentanyl or something. Some billboard.
Oh, wrong task.
Don't let hair with riders. Something about sleighs. I'm like, ride your sleigh. I don't know. I'm like, that's nice. Bring some Santa into this.
I remember. Santa cocaine. El Chapo. Santa's drug running. That's some biz. Hold on. Oh. Yes. I know, but I know what I'm doing. I just don't want to do it.
Alright, did we get something like this? Okay, the first thing we have to do for both of these is distribute. So over here, if I distribute the 3 to the n, I get 3n. 3 times -1 would be -3. Then I leave that +8 there. Then in my next step, I can combine these like terms, right? -3 plus 8 is 5. Plus. Then over here, same idea. Distribute that -5 through. So -5 times n is -5. -5 times -1 is a +5. So it's a negative times a negative. Then we have plus -2, which is the same as -2. Combine my like terms. 5 minus 2 is 3. Good with those? Alright. Then another little practice exercise before we get started. On these, we want to solve for the variable d. So, take a minute or two here. Try to solve each of these for d.
Already covered it. I like that put D in front of the numbers because then I put like D18 and then I put, wait, bingo.
Right? I just kind of naturally switched it to 3D instead of D3.
Did I keep the -13 in parentheses?
No, you can just that is -13. we get 3 for the first one and 2 for the second one. So I bet on the first one at least, you were very tempted to distribute this D through, right? Which would work. I mean, we could do that. We could say we'd have 12 equals 4D minus 1D plus 3, and then combine my D's, get 3D. But it's a lot easier if I have 2 numbers inside of the parentheses to just go ahead and do that addition or subtraction first, right? So 4 minus 1 is 3. And I can just write that as 3D and solve that 2-step equation.
You should technically supposed to and as goes.
You're supposed to do what's inside the parentheses first, exactly.
I don't remember how pendas goes. I know parentheses, and then multiplication before, multiplication division before. I think it's
You're right. So what's the E stand for that you're missing? PEMDAS. What's the E stand for in
equation.
PEMDAS? Exponents. Bingo.
I don't know.
An exponent?
I know it is, but I don't know.
Like, that's an exponent. 4 to the second power.
That's 16.
Correct.
Yes.
All right. So let's introduce a little bit of vocab now. Start talking about arithmetic sequences. All right. An arithmetic sequence, right, so you need to write this down on your notes, is a sequence where the difference between any 2 terms that are right next to each other is constant. Any 2 consecutive terms. I guess probably should add that in there. 2 consecutive terms, meaning they're right in a row. So if I look at this example here, 2, 4, 6, 8, 10, I'm adding the same number every single time, right? We're saying the difference between any 2 terms in a row is 2, right? To get from 2 to 4, I added 2, add 2, add 2, add 2. We call that number that we're adding every time, okay? Or if we think about going backwards, it would be the number that we're subtracting every time. We call that the common difference, okay? That's the next vocab thing on your notes. Okay? It's the constant distance between 2 terms. And we use a lowercase d to denote common difference.
This is on that big vocab sheet we gave us like a while ago.
That was all right triangle stuff. Alright. If you want to make a note, another way of thinking about the common difference is just the number we add each time. So in this example, my common difference is 2, right? I'm adding 2, adding 2, adding 2, adding 2. Now that number could be positive or negative, right? I could be adding a negative number every time. Give me a second to finish copying these.
I was supposed to work a double shift on Saturday. Also cut it because they hired too many people to afford to pay. Yeah, but I took someone's shift to like. I need you there. You guys need to help it. Yeah, I will. And some of those managers need to look at all that. I got in trouble because I didn't wear makeup yesterday. And it's required to have 3 items of makeup. I
Really?
had chapstick and mascara on. I needed
Chapstick.
cosmetics. And they yelled at me, so I was upset because like my face is in breaking out and stuff. I'm pretty sure I'm getting rosacea on my cheek. And I don't want to do anything. They yelled at me.
Alright, let's take a look at a few examples here and determine whether they are arithmetic or not. Right? Remember, arithmetic just means I'm adding the same number every single time. So, let's do a couple together. To get from 5 to 8, what do I have to do? I'm adding 3, right? How about from 8 to 11? Plus 3, 11 to 14, plus 3, 14 to 17, plus 3. Is this sequence arithmetic? Yes, right? I'm adding the same number every time. I'm going up by the same amount every time. Therefore, yes, number 1 is arithmetic. Yes.
Yeah.
Okay. Let's do 3 together, and then I'll have you guys do the rest of it. All right. So we just want to do the same thing. To get from 1 to 2, I add 1. How about 2 to 3? I add 1. So it's probably going to be arithmetic, right? I can just stop.
That's 2 and then 3.
Oh yeah. Then I add 2, and here I add 3.
Disgusting.
So this is not arithmetic. I am not adding the same number every time. Okay? Even if we add the same number a couple of times, we have to check and make sure that's true throughout the whole sequence in order to say if it's arithmetic. Right? So you guys go ahead and try 2, 4, 5, 6.
No, I don't like it.
I think Wednesday. Because we normally do review like a day or so before the test. And the chapter questions ain't due until Wednesday.
What is the term?
Take a look at that here in just a second.
Is spelling error? Or is it like real life math here? Hoping it's not.
Well, that's what that does.
It's wrong.
That isn't an arithmetic.
Poking next
Yeah.
term, like whatever
It's
term
gotta be
we're
the
talking
same
about.
here.
The 50th term would be the 9 millionth term. We're just going to do practice grade assignment.
Oh, of course.
Alright, so did we get yes for number 2? Okay, even though we aren't going up by the same number, we're going down by the same number. Right? We're subtracting 7 every time. Right? That number is the same, so this is arithmetic. Same thing for number 4. I'm subtracting 2 every time. In number 5, I'm close. I add 10, then I add 5, add 5, add 5. Since all those aren't the same, this is not arithmetic. And then at number 6, I'm adding 12 every single time. So this is arithmetic. All right? Good on determining whether a sequence is arithmetic or not? All right. Then let's define the nth term of an arithmetic sequence. Okay. The nth term. Okay, this just means how to write an equation for any term in the sequence. So a sub 1, okay, means the first term. D is the common difference. Okay. Then n is whatever number term we want. So if we want the 50th term, we would substitute 50 in place of n. Okay, but we can just leave that as n if I want a generic formula. Okay, a generic equation that would tell me any term in the sequence. So let's take a look at using this. Okay, so on your directions, it says we want to first write a rule for each arithmetic sequence, and then use that rule to find whatever term in question. In this case, we want to use that rule to find the 24th term. So if we think about that rule that we just wrote down, a sub n equals d times n minus 1 plus a sub 1, we need to think about the different pieces of information we need to write our rule. Okay? Whenever we write the rule, I'm always going to leave n as n. Okay? I'm going to leave this a sub n here, and I'm going to leave n here. So the two pieces of information I need that should actually be numbers when I write my rule are my common difference and my first term. Okay? Well, what is the first term in this sequence? -5, right? So my a sub 1 is -5. Now, I can also get my common difference. Okay, what is my common difference in this sequence? What's that? Adding 4, right? So I'm adding 4 every single time. -5 plus 4 is -1. Plus 4 is 3, plus 4 is 7. So my common difference, we say, is 4. Now I can just take those two pieces of information and plug them into my formula. So I can say a sub n equals 4 times n minus 1 plus -5 or just -5. Now this rule will get me any number in my sequence. Okay, we can just double check it here. We don't need to do this every time, but just to show you guys what we're doing. If I want the first term, okay, well I can plug 1 in and say a sub 1 is equal to 4 times, and I'm going to plug that 1 in for the n. So 1 minus 1 minus 5. So we get 4 times 0 minus 5. Would just be -5. If I want the second term, I would say a sub 2 equals 4 times 2 minus 1 minus 5. So we would get, this would be 1, right? So 4 times 1 is 4, minus 5 is -1. Okay, so we can see that this rule is going to produce every number in the sequence as we go. Okay, and again, we don't need to do this part. Okay, I'm just showing you what we actually got. What we do need to do is find a sub 24. Right? That's part of this question. So I want to use this rule to find the 24th term in this sequence. I'm going to say a sub 24 equals 4 times 24 minus 1 minus 5. So what do we get if we plug that into the calculator? Is that what everybody else got? Right? So these problems have two answers, right? They ask you for two things. First, they ask you for the rule. So this is the first answer. And then they ask you for the 24th term. So this is my second answer. We need to write the rule first, and then find whatever term we want. Okay? You okay so far? All right, let's do one more of these together, and then I'll have you guys try a couple. All right, so here is my new sequence. I need the same two pieces of information, right? In order to write my rule, I need the first term. I need my common difference. So what's the first term?
20.
20.
And then common difference is 9.
Almost.
Negative 9?
Negative 9. Right? If I'm subtracting every time, if I'm going down, that common difference would be negative 9. Right? So I can take these two pieces of information and plug them in for D and for A sub 1. Get that my rule, A sub n, is negative 9 times n minus 1 plus 20. Okay, now in this case, we want to find the 15th term in the sequence. So all I want to do is plug 15 in for n. So I'll say A sub 15 is negative 9 times 15 minus 1 plus 20. So what do we get for that? Negative 106. Okay, so our two answers. First, our rule. A sub n equals negative 9 times the quantity n minus 1 plus 20. And then our second answer, A sub 15 equals negative 106. All right. Feeling okay with these?
Yeah. I hate you.
Sorry.
The dog.
So you guys go ahead and try the next two, right? Using the same process. So write our rule by finding A sub 1 and the common difference. Yeah, negative numbers aren't very fun because they usually mean you're in debt or something bad like that.
Yes.
I would probably disagree with you on that one.
I was very happy to give you some of that because you like it so much.
Oh, I got Tyler such a cute birthday gift.
Yeah.
I got him this like big, like Pikachu like stuffed animal. She likes Pokemon, and then he's been like really wanting. Okay, you know what Funko Pops are? They're like a collectible, like little
Figurine.
kind of like bobblehead type thing. Well, it just came out with like Funko Pop cereal. He's been really wanting it, so I got him the Pac-Man Funko Pops.
Nice.
Yeah, I know.
I think they had a Bob's Burger one too. Okay. It was like a Bob's Burger. It was like a Rick and Morty, I think.
He's not even gonna eat the cereal. He's just gonna collect it. I thought that was nice. And then like for Christmas, I'm gonna get him like new shoes and an outfit. Cause like the shoes are flapping. That's gross. Big shoes. I mean, who wears clothes like to work and stuff? Well, he's been complaining about.
You listen. My eyes burn every day.
That's your brother. Stop it.
Lately,
Work was so busy this weekend. It felt like Black Friday all over again. It was bad.
It's just going to get worse.
I know. I even had to park in the back. I couldn't even park up front because the traffic was so bad. Almost sent me late to work.
Oh, no, it's so long.
Yeah, I'm like regretting like, oh yeah, let's go work out.
Me and my mom went there.
I think I get holiday pay. I got like time and a half of Thanksgiving. Yeah. So.
Me and my mom went down there last year, Christmas Eve. Nobody was in the mall at all. Like there was, I thought it was gonna be packed. Me and my mom both thought it was gonna be packed. There was hardly anybody in there. I was like, wow.
Go ahead and try both of these numbers, 9 and 10.
Yeah. I'm sorry. Okay. Well, what do you want from me? Hey, will we be friends? If I had like something, she knows how to feel about this. I told her about that. She knows how I feel about him. Like I've talked to her. And I talked to her about her 38. And I talked to her about it. I told her how I felt, and she said sorry. I just said, no, I don't. I came to school and I didn't know what was going on, and she was just I had to find out from my sister. Okay. So sorry for being. Which makes sense, right? All I want to say is I don't want no beef between us. You're like one of my best friends, and I can talk to you all the time. So are we cool? Happy belated birthday.
Look at each other. Use my friend. It's okay. That's how you show us.
Hey!
That's all you want.
I love them.
Can I do it? Show us.
You can do it to any song. Like it goes with everything. As long
Even
as
song
you
you
follow
don't think
the-
I get my brain.
I think you can do that.
Yeah,
I think you can.
yeah. I was apologizing like, you want this? I don't want to throw it away.
I mean, I got it. Or for somebody.
Yeah, I just
Yeah.
can't get it because it hurts my teeth.
My birthday yesterday?
Oh, the Bible.
No. Well, I wish I had.
Oh,
That sounds really bad. She got me a gift card to Foot Locker. I was shocked at Foot Locker. She's like, "Do you want to apply here?" I said, "No, I'm dirty." And I can't even use the gift card.
Okay,
I tried one
I
on the
understood.
website and
it's
I didn't
fine.
know what information. Yes, they wouldn't even let me put it.
Oh my
I'll take
god.
my gift card. I'll take it from now.
Huh?
I'll give you
I'll
the
figure out how to
just
use
as
it.
Oh, sorry.
$50.
Oh, wow.
Why would she give you a gift card for a place you want to work at?
I only asked for money. I didn't ask for gift cards. Just give me cash. That's all I need.
I'll tell my dad if I work at. He's like, you want that, or do you want to just give you money?
I don't want gift cards. I need a whole lot of cash. Because then once people give you gift cards, you can't put on your bank account, and that's a problem. Because I'm trying to get up there.
You're trying to get what?
Money. A lot of it.
Yeah. Did you just get that one?
Yeah, but I hate it. I know, that sounds really privileged and, like, up there, but, like, it's old and outdated, and I need it.
Is it new to you or like new to them?
No. It's not new. It's an iPhone 6. I have no patience.
iPhone 6?
Alright, for number 9,
I know.
did we get a sub n equals -3 times n minus 1 minus 6 for the rule?
Yes.
And then for the 38th term, negative 117.
Yeah.
Oh, that's better.
Oh yeah, I got it.
So if it has like the A, like a 38 or a number over it, that's what it wants us to know, and then we just plug all it.
Yeah, so first write your rule, and then just plug 38 in for n. Yep. All right, for number 10 then. Oops. Where's the- So first, I need to write my rule. So I need the first term. First term's 8. And I need my common difference. What is my common difference here?
1.5.
1.5. Going up.
Negative.
No,
I'm adding 1.5 every time.
I can't count that. Leave me alone.
If I'm going up by 1.5, it'll be positive. So if I plug those two numbers in, my rule will be a sub n equals 1.5 times n minus 1 plus 8.
cool.
And then if I want the 48th term, I can say a sub 48 equals 1.5 times 48 minus 1 plus 8.
62.5.
62.5.
Oh, so really, you don't even have to solve this unless you have another plug in.
Okay, this is
Yeah.
easier to, what's that one? It's gonna get harder.
I got 78.5.
78.5?
Yeah.
You are wrong.
Oh, wait, never mind. I
I can-
subtracted 8 instead of adding 8.
I'm right.
Alright, 78.5. Thank you.
My bad.
You're good. Good so far? Any questions? Alright, then the last section on here. We're given a little bit different information. Okay, I'm given just two terms in the sequence. I'm told the first term is 3, and the third term is negative 7. I know for sure it's an arithmetic sequence, but just from this information now, I need to write my rule. So, I know my first term, right? But I don't know my common difference. Right? Those are the two things I need to write my rule. Given these two pieces of information, though, how could I find my common difference? Any ideas?
You just, well, I mean, you obviously have to get that number in between.
Alright, so what we want to do here, okay, for any problems where we were given a first term and some random term then in the sequence, I'm going to plug my 3 in for a sub 1. But then I'm going to plug this random term in for my a sub n. Okay, so I'm going to say a sub 3, that's my n in this case. I'm going to plug negative 7 in for that, equals, I don't know my common difference, but what I do know then is this is the third term. I'm saying that n is equal to 3 in this case. So I'm plugging all of this information in, right? This is my a sub 1, this is my a sub n, this is my a sub n, this is my n, right? My n is 3, my a sub n is negative 7, my a sub 1 is 3. Okay, so I'm plugging all three of those pieces of information in, and now I'm solving for the common difference. Right? This looks like what we did in the warm-up now. Right? How do I solve this? How do I solve this for D?
Simplify.
Oh.
It'd be
So
negative
that's-
7 equals 3D
2D.
minus.
Plus 2.
3 minus 1 would be 2.
Oh,
And then you subtract operating.
I keep thinking we would have to like distribute.
It is tricky because whenever you see parentheses, you automatically think distribute. Right? But in this case, it's way easier to just do that subtraction since both of those are numbers.
D equals
Yep. D equals negative 5. We're not done yet. Okay? The ultimate goal is to write the rule. So we have just now collected all the information we need. Okay, I have a sub 1 equals 3 and d equals negative 5. Right? So I'll write that down here. So I've got a sub 1 equals 3 and d equals negative 5. Now I can write my rule. Right? Following this pattern, I can say that my rule is a sub n equals negative 5 times n minus 1 plus 3. So we still need those same two pieces of information as the last set of problems. This time I just have to do a little bit of work to find my common difference. Okay? Just making sure we're okay. Let's do one more together, and then I'll have you guys try a couple. Alright, so I'm given my first term and my 24th term here. So I'm going to say that 24 is my n, and 6 is my a sub n. Right? So I'm going to say 6 equals d times 24 minus 1 plus negative 17 or minus 17. Now I want to solve for d. So 24 minus 1 is 23, so I just get 23 times d minus 17. Add 17 to both sides. Get 23 equals 23 times d. Divide by 23 and we get 1. Our common difference is 1.
Uno.
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 Nope. Alright, so my common difference is 1. My first term is negative 17. So my rule, my final answer, would be a sub n equals my common difference of 1 times n minus 1 plus negative 17 or minus 17. Questions? All right, we got 6 minutes. If you guys finish the last 2 here, no homework.
Or don't do anything.
I've got stuff ready to go.
I want some Chick-fil-A. So
Well, could you actually give it to me? Because
Let's see
I'm
if I
not
can
going to
grab
be
this
here
one.
for like the next 2 days.
Yes,
I
will get that to you.
Why
I
are
don't
you
have the
drawing
next
this?
2 days stuff ready, but I'll get it to you today.
Thank you.
You're gonna call cheese now. We watched me and my sister watch
I don't know.
Yeah,
Oh.
copies.
She's hot. She's a hot. I like that.
Guns are crazy.
Stop. Stop with that. That is sacrilege if I've ever heard of it. Stop. It's disgusting. What is
These are
wrong
my
with
girl sweatpants, and I don't know what.
Especially when her eyes started to bleed, she had an anagram down the back of her shoulder. Oh,
you?
get that honey white on her stash.
That's actually disturbing, Mikey. I'm scared. I would just say that.
I don't know if I'm interested in that or she's just hot.
I don't know. What you just said was God disturbing.
You're not being very helpful.
Actual sacrilege.
I don't know exactly where it is.
Stop. 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 That is actually horrible. Damnation for that section. Do it.
Wait, we just have to do the 14?
Yeah, we did 11 and 12 together.
I don't know what that is. Yeah, I won't take this. I'll be okay. Bitch, I don't understand this. I'll break.
You're so annoying.
Attention.
Yeah.
At least he's aware. right top of it.
Wow. Why did I get 16? I switched something.
So that is there.
Yeah. Oh.
Is that decimal? Can we get decimal?
Oh, decimals, wow. Sometimes when I get decimal, I think I'm wrong.
This one's a better directions.
And I hate practice. Oh, well, practice of this decimal.
Yeah, it's just division.
No, wait. Now that I got shmoney, I can get new hair. That's fine.
How much money should you
Oh
get?
yeah, it's Foot
Around
Locker.
300.
It's Foot Locker South Edge.
Thank you so much.
Okay,
Can I use this pen?
All right, for number 13, I got a common difference of 8. So my rule was a sub n equals 8 times n minus 1 plus 2. Okay, you okay with that one? Then for number 14, on this one, my a sub n would be 123, my n is 33, and my a sub 1 is negative 9. So I get 123 equals 32d minus 9, add 9. 132 equals 32d, divide both sides by 32. I don't know what we get for that.
Good try, Tommy.
4.125. So then my rule, a sub n equals 4.125 times n minus 1 minus my first term of 9.